Continuity. Continuity is essentially next step further from limits. Continuity is a concept that bothers about the destination as well. When we were talking about limits, I told you that limits do not bother about destination, but it is only concerned with the journey. Okay, what is happening as x is tending towards some x naught? What happens to the function at x naught? Okay, limits are not concerned about it. Okay, all we mean to say is that it should tend towards some finite number L, right? But when we are talking about continuity, when we are talking about continuity, we mean that this function should not have any break. Okay, so what essentially we mean is that, just see, what essentially we mean is that the function, this is my x, this is my fx, the function should be drawn in a manner, it should be a function which could be drawn in a manner where you do not have to drop your pen at all. You do not have to drop your pen at all. Okay, so which means that the function would be continuous, which means that when as x tends to x naught from left side or right side, it attains the same value. The function attains the same value, which is fx naught. In fact, not even some L, it should be exactly fx naught. So that is what is the concept of continuity. The function should have same limits from both the sides plus the same value at the point of concern. So the point of concern x naught. So limit x tends to x naught, fx should equal to fx naught. Okay, so the requirements for continuity are as following. Number one, limit of the function fx should exist, okay, as x tends to x naught, both from right as well as left, okay, both from right as well as left. And fx naught should be defined. That's the number two. Fx naught should be defined. And number three, and the most important concept, number three is that the limit x tending to x naught minus fx should equal to x tending to x naught plus fx, and should equal to actually the limit of the function at x naught, which should equal to the functional value at x naught. In case these three, any of these three is not met, the function is said to be discontinuous, because that would mean that the function has some break somewhere. Say you have a break in the function here, then this is not a continuous function. Say that, you know, your function is x plus 1 when x is less than 2, it is x plus 2 when it is greater than 2, and it is, say, some value 3.5 when x equals to 2. This will give me a break. This will give me a break at the point 2. So at the point 2, the function will not be continuous.